Okay. So please, in the future, when you're handing in your quizzes, please write down your ID number and your name, all right? Otherwise, you're giving me a lot of trouble, okay? And also, one other thing is that make sure that you're doing the right quiz. Some of you handed me work which is from last year's quiz. Some of you handed me stuff from 2019. You must be still living in 2019, I guess. It's 2020, guys, now, not 2019. Yeah? So please make sure that you hand in the correct quiz. Otherwise, you get the 0 mark. You should give me the incorrect quiz, right? Okay? Right. Now, before I start, I want to just summarize what I did in the last lecture, which was the lecture on Thursday last week. Right? I talked about how come there are so few of you coming today. Is it 9 o'clock too early or what? Anyway, I talked about different kind of variables. There are qualitative variables and quantitative variables. In this course, we mostly talk about the quantitative variables. There are two kinds, the discrete and the continuous. Okay? And so if you have a discrete random variable, then the probability structure is described by what is known as PMF. And if you have a continuous variable, then it's described by what is known as a PDF, or probability density function, right? So this is stuff we did last week. If you have a variable x, then the CDF, or the cumulative distribution function, is defined by this. Okay? And the expected value, or the population mean, is denoted by the expectation of x. The variance of x is defined by this. The standard deviation of x is the positive square root. And this denotes the nth moment of x. Okay? Then I talked about independence of events. You say that two events, A and B are independent if this holds. I'm sure you know this from your A-levels, right? And you say that n events, A1 to AN, are independent if this is true, right? And it translates naturally into events. You say that x1 and x2, two random variables, are independent if this is true for all x1 and x2. And you say that n random variables, x1 to xn, are independent if this is true for all x1 to xn, right? Okay, guys? Then I define what is meant by a random sample. A random sample, x1 to xn, is a random sample if they are independent and they follow the same distribution. In other words, their CDFs are identical. The CDF of x1 is the same as the CDF of x2 up to the CDF of xn, right? Okay. Then I defined what a sample mean and a sample variance is. The sample mean is defined by this term here, which is denoted by x bar. And the sample variance, there are two formulas denoted by s squared. This is a biased version, and this is an unbiased version. I will talk about bias later in the course, so you need to be patient with me, guys, right? Okay. Then I derived the mean and the variance of x bar. So this is the derivation for the mean of x bar, which turns out to be mu. In this case, mu is the expectation of x1 up to the expectation of x1. In other words, each of these elements here, each of the expectations here is equal to mu, right? So in other words, mu is the population mean, right? And the variance of x bar is derived, can be derived like this, right? And here, sigma squared denotes each of the elements inside the square brackets. So the variance of x1 is sigma squared, variance of x2 is sigma squared, and so on. So in other words, sigma squared represents the population variance, right? The population variance of each of the variables, x1 to xn. All right, guys, any questions so far? I mean, if you have questions, why don't you guys want to Zoom me? I asked you to Zoom me 24/7, but none of you do. Are you guys afraid or what? Yeah? If you have questions, please, I keep my Zoom 24/7 on, so you can Zoom me anytime. Yeah? So before I go ahead, I want to do some examples. So the first example is all right. So I want to do this example. So just to, I mean, you guys, I'm sure you know, the more examples, the better you learn, okay? So let's see, do you guys know this distribution, X lambda? What distribution is that? You must have done that in probability 1. Come on, guys. What does this denote? Exponential distribution, yeah. So the expectation of x is the integral from 0 to infinity of x fx dx, which is 0 to infinity of x lambda e of minus lambda x dx. Now the way to do this integration is you can pull the lambda outside. I'm going to make a substitution. I'm going to set, so x is y divided by lambda, so dx is dy divided by lambda. So this is a substitution I'm going to make. So under this substitution, this will become lambda, 0 to infinity, x will become so this is 1 over lambda right? Now, do you know anything special about this integral, guys? Is what? Sorry. Do you know something called the gamma function? Do you know? Anyone heard about the gamma function before? Yes? No? Come on, talk to me, guys. Why? If you haven't heard about it, it's okay. I will talk a slide on it's okay if you haven't heard about it. Gamma function is defined like this. The definition is this. Gamma at a is defined as the integral from 0 to a of t. This is the definition of a gamma function, right? And is defined over all a belonging to the real line, but not equal to 0, minus 1, minus 2, etc. Right? So it's defined over these values of a, right? And some properties of gamma function as follows. Gamma at a plus 1 is 8 times gamma at a. Gamma at n is same as n minus 1 factorial. Gamma at 1, gamma at 1 is equal to 1. And gamma at half is equal to root of pi. So if you haven't heard about the gamma function, these are some details about it, right? Okay, so what I have used here in this step, sorry, can you see this here? From this line to this line, I have used the definition of the gamma function, right? And gamma out 2, because of this property, gamma out 2 is 2 minus 1 factorial, which is 1, right? And therefore, this becomes 1 divided by lambda. Okay, guys? So gamma function is a very useful tool in many areas of mathematics, including statistics, right? So if you don't know about it, please. Anyway, you don't need to copy anything I write down, guys. I will scan it straight out after the lecture, right? So this is the first property, guys. This is the first property. The second property is the variance. To find out the variance, we need to use this formula here. I'm sure you know this formula, right? So we already know what the expectation of x is. So it's going to be this, right? So the expectation of x squared I'm going to make the same substitution as I did over here. So under that substitution is going to be 1 over lambda okay, so this will be 1 over lambda squared, 0 to infinity, y squared e minus. Okay. Now this guy here, what can you say about this integral, guys? It's a gamma function at what? Gamma function at 3, exactly. So this would be 1 over lambda squared. Gamma 3 is 3 minus 1 factorial, which is 2, right? So this is 2 over lambda squared. Okay, so hence, the variance of x is 2 over lambda squared minus 1 over lambda squared, which is 1 over lambda squared. All right, so this is how you find the variance of X, right? The next one is the nth moment. The nth moment is this guy here, right? So to find this, you do this, right? I'm going to make the same substitution as I did in part 1. So this is going to be 1 over lambda, 0 to infinity, right? So this will be Are you guys with me? Yeah? Okay. Now, by the definition of the gamma function, this would be gamma function at n plus 1. Okay? Remember, it's always the power of y plus 1. So the power of y is n, so it's gamma at n plus 1. So this would be n factorial. Okay, so this is the nth moment of the exponential random variable. All right, so that's part 3. Now, oh, what did I do? Is it the same thing here? No, just a minute. Oh, sorry. It's my stupidity. Excuse me. It should be lambda here. This should be lambda here, so the lambda cancels. And the same thing here. This should be lambda. This should be lambda. So you should have pointed that out to me. This should be lambda, guys. This should be lambda here. The lambda and the lambda cancels. All right? Did you spot? Hello, guys. The PDF of exponential is lambda times this. So there's a lambda outside which cancels with this lambda, right? So you get lambda power n in the denominator. Okay? All right? Okay. Now the next part, I'm trying to remember the next part of the question. Is the joint PDF. All right. This is clear, by the way, guys. Okay, the joint PDF is because x1 to xn is a random sample, they are independent, right? So you can write this as this. That's using independence. Okay. Now, I shouldn't use this notation, but because equal means for continuous is 0, but I mean, okay, let's forget that for the moment. But this one is okay. So this will be lambda power n okay, so this is the joint probability density function. Once again, I'm abusing my notation because when I put equal for a continuous variable, the probability is 0, but just forgive me for that, okay? Okay. Now the next part is part 5, the joint CDF. The joint CDF of the random sample is the probability that of this, right? Once again, because x1 to xn are independent random variables, you can write this as the product Now, do you guys remember from probability 1 the CDF of an exponential random variable? Yes? No? Exactly, yeah. All right, this is the, just look back in the notes for probability 1. Or you can look at the handout I gave you at the first day. Do you guys have a copy of this? This gives you all the distributions you need to know, plus the PDF and the PMF and the CDF. So if you look in this, you should know how I got this, okay? I'm sure all of you have. If you don't have a copy, please see me, okay? So that's the joint CDF. All right, guys. The next one, we want the mean of x bar. Remember, on Thursday, I showed you that the expectation or the mean of x bar is mu, right? Now, mu is the population mean, which we already worked out. So this will be, all right, this is from part 1. Okay, and the variance of x bar, once again I showed you last Thursday that the variance of x bar is sigma squared. And sigma squared is the population variance, which we already worked out, which is the variance of x basically, which we showed that to be equal to 1 over lambda squared from okay. So the mean of x bar is 1 over lambda, and the variance of x bar is 1 over lambda squared. Okay? Any questions, guys? Is it? All right, so that's end of example 1. Now, I also want to do one more example, because this example I took is discrete, sorry, it's continuous. Then example 2, I mean, as I said, the more example you do, the better for you guys, all right? Example 2, suppose you guys okay? All right, guys. All right, so this is example 2 for a discrete distribution. Example 1 was for a continuous distribution, right? You guys okay? Some of you look tired. Or did you have enough sleep or what? All right, now, do you know the Bernoulli distribution, guys? I'm sure you must have done that in your probability 1 or even before that. A Bernoulli you say that X has a Bernoulli distribution if the probability that X equal to X is equal to 1 minus P if X equal to 0, and P if X equal to 1. All right? So this, I'm sure, does this ring a bell? Yes? Yeah? Now, you can also write this as yeah, you can write this formula, which is a complicated, not complicated, but it's in a compact manner. So I mean, instead of writing this, if this, you can write it like this, because if you put X equal to 0, this becomes 1 minus P. And if you put X equal to 1, this becomes P. So simple, right? And the CDF, the CDF for the Bernoulli distribution, you should recall from last year, probability 1, you will see that is 1 minus P if X equal to 0 and 1 if X equal to 1. Okay, this is the CDF of Bernoulli. And which, once again, instead of having this if and if statements, you can write it like in a simple way. You can write this as 1 minus P to the power 1 minus X for X 0 or 1, right? Do you see why? Because if X equal to 0, this becomes 1 minus P, and if X equal to 1, this becomes 1, right? So it's easy, right? Okay, now let's look at the first part, the expectation of X. What's the expectation of X for a Bernoulli is easy. So it's 0 times 1 minus P plus 1 times P, which is P, all right? Part 2, the variance of X. Yeah, so this is going to be 0 times, or 0 squared times 1 minus P plus 1 squared times P minus P squared. So this is going to be P times 1 minus P. So that's your variance of X. Part 3, the expectation of X to the power n. So it's going to be 0 to the power n times 1 minus P plus 1 to the power n times P, which is P. All right? The next one, part 4, is the joint. The joint PMF is going to be all right, so because of independence, you can write this like this. And we know that the PMF is this. This is the PMF of the Bernoulli. So I'm going to substitute it. I'm going to put it here. So it's going to be okay, like this. Now, simplifying this, you will get 1 minus p to the power n minus the sum of xi. All right, so this is the joint PMF of the random sample. Now, do you guys, I thought, I've been teaching statistics courses for many years. A lot of people have problems going from this line to this line. Do you guys? No? No trouble? I know, but I can tell you, like, I've seen many people having trouble simplifying products of functions. That is why maybe I would do it on another day, not today maybe, but you have to get your algebra correct. When you simplify products of functions, it's often very easy to make mistakes, right? So when you simplify this to this, you should take the sum of this, which becomes this, and the sum of this, which becomes this, right? So if you're not confident about this, I can have another lesson, maybe talk about it on Thursday or something, all right? But not today, okay? All right, guys. And the next one, the joint CDF of x1 to xn is once again using independence. All right, and this is the CDF of a Bernoulli, which I just mentioned a couple of minutes ago. It's going to be product okay, and once again taking the sum of this, the product of this, you get 1 minus p okay. So this is the joint CDF of the random sample. And next one is the mean of the sample mean. When I say E always means expectation, which means the same as population mean. So what you're talking about here is the population mean of the sample mean, right? Which is equal to mu, which is equal to the expectation of x, which I showed you to be p, right? And the variance of x bar is equal to sigma squared, which is the population variance, which is the variance of x, which is equal to p times 1 minus. Oh, sorry, there should be an n here. I forgot to put the n. You should have corrected me. There should be an n. Also here, there should have been an n here. There should have been an n, because if you look at the notes, I gave you on Thursday, is sigma squared divided by n. Remember, the variance of x bar is sigma squared divided by n. So that's why there should be an n all the way, right? And the same thing here, there should be an n here all the way, okay? I'm sorry about that. Okay. Right? Okay? Is that okay, guys? Just because let me take you back to what I did last Thursday. You may remember. You see, this is what I talked about last Thursday. the variance of x bar is equal to sigma squared by n, right? Okay, so you have sigma squared by n, where sigma squared is the variance of x. So this becomes this, right? Okay, guys, those are two examples. I think that's enough for the examples. Now I'm going to move to a different topic now, which is about summary statistics. Are you guys okay? Suppose you have a data set x1 to xn, and you want to be able to say what the main features of the data are, right? So in other words, things like the mean and the variance and so on, okay? So I'm gonna define a few things. The first thing is order statistics. Order statistics are data arranged in increasing order, right? So this would be the smallest data value, and this would be the largest data value, right? Okay, so I use the subscript in brackets, then the number. So if it is 1, in brackets 1 means it's the smallest data, brackets n means the largest data, right? Okay, then B is the mean, or the sample mean, which I have already defined. It's defined as x bar. I'm just repeating it from last week. The sample mean gives a measure of the average value that you would expect. For example, average height or average weight, things like that, okay? Then C is the sample median. The sample median is defined by one of the following, right? It's equal to this if n is an odd number, right? And it's equal to this if n is an even number, right? Okay, the sample median, roughly speaking, it means the middle value. So if you arrange the data from the smallest to the largest, the middle number is known as the sample median, right? So, and this, mathematically speaking, is defined by one of these, right? And the next one, not really, not that I've, not something I know of really. Some people, yeah. The next one is the the sample pth quantile. P is a number between 0 and 1. So for example, if p is a half, that would denote the median, right? Okay, if p is 0, that would be the smallest value. If p is 1, that would be the largest data point, okay? And it's defined by the following. All right, this is the definition for the pth quantile. Quantile, or some people use the word quartile. They are the same thing. Quantile and quartile are the same, right? Okay. Are you guys familiar with this notation, the square brackets? Don't tell me no. Oh, come on, guys. Why you keep saying no? This notation, I'm sure you've seen this before, guys, haven't you? It's the largest integer less than or equal to x, right? Okay. So if, as I said before, if p is 0, which is the same as saying if r prime is 0, then q of p is equal to the smallest value, smallest data point, and if r prime is n, right, then q of p is the largest data point. As I said, I will do a couple of examples on this later, but for the moment, just imagine this formula. But I will do some examples later on. Okay. The next one is E. Sample first quantile or quartile, they are the same thing, is defined as Q at p equal to 0.25. All right, so you put p, all right, so that's the definition. And sample third quartile or quantile or quartile is defined as Q at 0.775. So you put p equal to 0.75. Okay. G. Come on, guys. Shh. You only got sample variance. Sample variance, I think I already mentioned last week what it is. There are two formulas for it. You have this formula. All right, this is the biased version, and the unbiased version is this one. So this is the biased version, and this is the unbiased version. Okay. So that's sample variance. The next one, come on guys, we have 3 minutes left, so don't be in a hurry. H is the sample standard deviation is the square root. It's the square root of the sample variance. All right, so it's either this one all right, or this one. All right, so that's the sample standard deviation. And I is the sample range. Sample range is just the difference between the largest and the smallest. So this would be X. Okay, so this is the sample range. Okay, and J sample interquartile range or quantile, doesn't matter which way you say it, is defined as follows, is the difference between Q 0.75 and Q 0.25. Okay, so these are basic summary statistics for any given data set, right? When I see you on Thursday, I will do a couple of examples on this, right? Okay. All right. Have a good day, guys. Tomorrow we have example classes. Okay. Make sure that you do come to your example classes. And if you have a clash, please come to one of the other example classes. Okay. This one. Yeah. I will scan it. I will scan this one and put it online. Yeah. Yeah. This should be 2. Just check it online. I changed it. It should be 2. I have already changed it. It should be 2. Next week, yeah.
Morning.